Hi, everyone. Hope you enjoy coffee and that you're all shaky and sweaty now.
Cool, so our next presentation is actually going to be quite magical. I have the pleasure of announcing the open sorcerer himself, Matt Podwysocki.
Yay!
Woo!
All right. Hey, that's the extent of my Swedish, sorry. Hello and welcome everyone to my talk about how we're all doing programming wrong, or at least you all are. And of course it has to be so because John McCarthy, the founder of Lisp and the creator of Lisp, tells us we're doing it completely wrong. So that's going to be the premise of our talk today, are we doing things wrong? And the answer is absolutely. At least you are. So I like alternative titles to my talks when I do them. So for example, this one is How I Stopped Worrying About Asynchronous Programming and Learned to Love the Observable. So that's going to be a lot of the main premise of what I do here. I could also do the flying of the hat, but no, let's just keep the hat on. So I also like to start out with a little bit of an asynchronous joke. I thought I had a problem, so I thought to myself, you know what, I'm going to solve it with callbacks and events. Now problems to problems to I. Yes, race conditions. So this will be a quick monad tutorial on how monads are really awesome. And if you don't like category theory, you can leave. Because after all, a monad is just a monoid in the category of endofunctors. It's the problem. I mean, come on. All right, that's the end of our monad tutorial. So I am a principal open sorcerer at Microsoft. You can find me on the interwebs there. I am very, very unoriginal when it comes to account names. So if you can find me in one place, you can find me other places. I happen to work for this particular company here, doing all sorts of things in terms of Internet of Things to reactive programming at scale. So I basically have my hand in a lot of places, but what's really cool is the fact that it's all open source, everything that I do. And since we're in Sweden, I thought I'd add a little bit of metal to it. So the thing that I'm really working on a lot with the community is the reactive extensions, and that's what most people know me for. So you can check us out, ReactiveX and ReactiveX.io, which basically has a number of languages that are supported, whether it's Java, C#, JavaScript, Ruby, Python, Swift, etc. And yes, I am a drug pusher. Now let's get serious here for a moment. Real time is really everywhere in everything that we do today. Whether it's on your phone when you're dealing with GPS, you're dealing with SMS, you're dealing with Twitter, everything, those push notifications that Apple, so nicely bugs you about. All of that data is coming at you at a high rate of speed. How do you manage it? Well, at a certain point, you just end up shoving it down your shirt because you have no idea what to do with it. It just comes at you too quickly. And especially if you want to start combining with other things such as weather updates and so forth, it just becomes really, really overwhelming. And to compound it, let's just face it, asynchronous programming is just awful. Because as you're trying to manage a couple of things of state, it just doesn't work very well. Apparently, this guy can't even figure it out either. So, I really wouldn't put too much thought into that. So let's see if we can fix some of that. Now, we've had some people, very brave folks, especially in the US, that have been trying to figure that. We had former President John F. Kennedy. We choose to solve asynchronous programming and other things, not because they're easy, but because they are hard. Well, he thought about that for a little bit, and then he realized Asynchronous programming is too hard to solve by the end of the 60s. Let's just go to the moon instead. So, damn, I thought Wikipedia was right on there. Oh well. So anyways, what we're dealing with a lot of the times is what we so lovingly call callback hell. And what that is really is all about having these complex state machines of where you're not quite sure where you are in the whole scheme of things, because all of these callbacks of saying, well, am I in the error state? Am I still good? What's all this state that's just hanging around, such as my movie ticket, my player error, and so forth? All of those things just kind of really get annoying. And you kind of lose your spot of where you are. So, in terms of your whole logic, it's just spread out throughout, and then your error handling is just sprinkled in as well. And what you end up with is something like a cow's head. And I don't like the pyramid of doom. I like cow's head a lot better because it goes out and then it comes straight back in. But you have no idea where the error handling even happens, quite honestly. So, when I do this, at least, I know you're playing with fire, and you know what happens when you play with fire. Yes, that's exactly how I feel right now, by the way, is that it really is an awful situation that I think we can make a little bit better through the things that we have today. And just as well, when we're dealing with event-based programming, it's just about the same kind of awfulness. In terms of when you're dealing with events, what you're saying to yourself is, okay, I have this global state here is down in some sort of state. When mouse down goes down, you're like, yay, it's great. Mouse is down and here's some state. When the mouse moves, we calculate some deltas and we do something with it. And then on mouse up, we just clear out everything and say we're not doing anything. And then we have to add our event listeners and then get rid of them after we're done. So to me, that's enemy of the state, and I'd rather run away. But it's like you're juggling a bunch of different things, because if I started wanting to do something with that data, it just becomes really, really unmanageable. So, how can we actually fix some of these problems that we've had? Well, in our callback hell example, we have promises that do exactly that. We can say player.initialize, then authorize movie, else they have a login error, then play the movie, else they're unauthorized, you can't see it, what have you. That's great, except it's not. And the problem is that in the built-in promises in ES 2015, ES 6, whatever you want to call it, lacks a notion of cancel. So you can say get data, then populate UI, but you can't say get data, then I forgot, I don't want it anymore. And it got so bad where the fetch API came out from Whatwig. So, this is the new way of doing XHR. And so what the number one issue was aborting a fetch. Oops. They kind of forgot about that. One of the fundamental things about XML HTTP request is you can abort it. Well, you can't with as a standard promise. So what you can see here is we have 204 comments, and we have 21 people talking about it. So I think you can kind of make a joke there on how many engineers does it take to cancel a promise. Anyways, just as well, we don't have a way of actually saying we're done. There is no such thing as finally either. So, in other words, we have this really great notion of a promise. It goes really fast, but we remove the brakes because, well, that just adds too much weight. So it's a little unsafe at any speed in terms of if you're really trying to do something useful. So why not talk about stream processing? Because stream processing is a way of dealing with more than one value. When most people think about streams, though, they tend to think about node streams. But let's be honest here. Node streams in Node, the first version, were completely awful. The pause method didn't. Data started whether you are ready or not. And you can't just say, I want 5 or 6, 7, 8 bytes and what have you. No, couldn't do that. And pause and resume were just really hard to get right. So what you ended up with was something like that. Sorry, kid. You called end before data. So streams 2, we added a few extra types like readable, writable, and so forth, and transform. But you still had to implement the read and the write methods and the transform. So it's still a really easy way to get tripped up here. And in addition, in streams 3, we have the ability to do batches and so forth. But still, it's still a tangled mess in terms of what it could be. Now what we're trying to do is we're trying to take the brilliant ideas from node streams and then force them into the browser. What could possibly go wrong? So the idea here is node streams. Think of it as node streams and promises focused on really low-level I/O. So I can take my readable stream, pipe it to my writable stream, and then I can have some promises for whatever reason to say whether it's done or it's not. But that's not super interesting. Let's talk about reactive programming because, well, that's what everybody is talking about nowadays, right? Well, then when people think about reactive programming, they're like, oh, yes, React. That's reactive programming, right? Not really. It's kind of, maybe. But let's actually talk about what that actually is. And what it is according to the dictionary at least, readily responsive to a stimulus. Okay, so it's active and already listening to events. Well, we've been doing that for gosh knows how long with jQuery. You say click, and then you say slide up. Duh. All right, there you go, reactive programming at its finest. And in fact, we've been doing this for quite some time, and the fact that we've been updating our spreadsheets for gosh knows how long, and then just suddenly the data changes without us having to do anything, other than the fact is that the cells change automatically for us. But you really want to know what it is? You really? All right, so you can read this in fine technical paper here, Special Purpose or General Purpose Languages by Gerard Berry. You can read it at Reactive Paper. But I know that when I hand you a academic paper, that's usually what's going to happen, unfortunately. Most people don't know how to read an academic paper, and I'm certainly one of those that only gets about the first paragraph and the last paragraph in. And even the most brilliant among us have problems with a lot of these things. But luckily, the Germans have a great word for this. It's the fear of academic papers, I think, something like that. But the Germans are really good at creating words that accurately reflect our problems. So instead of all of that, maybe you can just stick with this. The intro to reactive programming that you've been missing. And I screwed up on that link, but whatever. You can go to just this gist here, and you'll be just fine. In terms of finding out what reactive programming, and as you can see, given the number of stars of 5,300 stars, there have been a lot of people that have been looking at it and finding a lot of stuff in for it. And yes, they kind of made fun of my documentation. Oh well. Now, let's talk about the elephant in the room. When people think about reactive programming, especially with observables and so forth, they think functional reactive programming. It's an entirely different thing. It's a notion of continuous time. It's a notion of a separation between behaviors and or things that have a constant value, such as a clock, and things that don't, such as discrete events, such as your mouse movement and mouse clicks. They might not necessarily have a consistent value. And the more along the lines is you have this notion of really type semantics to be able to describe what exactly it does. Nobody in the JavaScript world has this. The closest thing maybe is Elm, but it's not functional reactive. They only deal with discrete events as well. So please stop calling it FRP, please. And you can call us reactive programming. You can call us compositional print. I don't care. So let's go back in time. How many people were actually born alive in 1994 here? Okay, all right, a fair number. I knew I was feeling old, but I didn't know how old. But there was a book out that came out, and it was The Gang of Four, and which pretty much codified the bunch of language design patterns. And they had a bunch of them that were kind of interconnected in terms of the relationships. But they never quite got the iterator and the observer together. And we quite honestly thought that was a mistake. So with the iterator pattern, we have that with ES 2015, where you can get an iterator, call next, and then you're done. But we've always had the subject observer pattern, which is more of a push-based mechanism. I give you a callback, and it gives me data. So when I start moving my mouse, I start getting data. Yay. But it had certain problems with it in the fact that it's not very compositional. I can't just, like I showed in the thing earlier with the event composition, it just doesn't really work. You can't just suddenly combine a mouse move and mouse down and so forth. So let's think about it in a more different way of saying, could we in fact kind of build off of this where it kind of is a more compositional approach, and that's exactly what what observables are. So let me ask you a question then. What's the difference between an array of values and of an event? Really? Nothing. They are both collections. And one you can think of, for example, this clicker here is in fact a database you can query. You can write maps and filters and so forth. And in fact, what we did is we did the math, and here's our category theory that I told you all about. And just to say our observer stuff, and here's our iterable stuff that we have in ES 2015, which has our iterator, next, and so forth. Well, we have all of those in a push context of on next, on error, and on completed. That's all you really need to know. It's not super, super complex. And in fact, if you know arrays, then you know how to deal with streams. So what we can do is we can write the vast majority of our code in these very flexible functions you should already know. For example, we have map, which takes a selector and basically then transforms, for example, from circles to diamonds. Filters out only things where we only want circles through the filter method. Merge them all together, so take a bunch of these streams, such as mouse move and mouse down, and merge them into one. Or we can call flat map, which is basically doing a map and then a merge together. And lastly, one of the most important ones is take until. So I can continue listening to my mouse move until mouse down and mouse move until mouse up happens. So let's actually take a look at some quick examples of how to do that. So in Netflix parlance, what we can do is we can say, all right, I want the top-rated films. So what I'm going to do is I'm going to take my video list, and I'm going to get my videos, filter them out where all of the things are rating of 5, and then put them all together, and I call for each and display the movie. Or I can call flat map, and it does just about the same. Okay? So what if I told you that what I just showed you there, you can do exactly with events in just the same way? Would that intrigue you? Yes, I like cat pictures, sorry. So let's take a look at mouse collections then. So what we can do is we can say dom.mouseDown, map, mouse move, and instead of that filter we had before, we can say take until, mouse up, and then merge it all back together. Or more precisely, flat map, take until, dom, mouse move, take until, mouse up. And what you just realized now is you're like, everything's a stream. This is great. Even if it's one value or multiple values, I have an answer to my question. Now, that's the real great part about it, because when you're dealing with callbacks and you're dealing with events, the problem is that you don't have a way of really passing this around. I can't pass you back a callback. That just doesn't really work. Instead, what we have now is with a promise is we have a first-class value to pass around to people, and we also have the ability to pass around this observable notion as well. So it's first class when I can pass it in, and I can return it from a function. Now, where does it belong, really? Well, we have the synchronous world and the iterable world in JavaScript, where you can call for each when you do filters and maps and so forth. And promises, we can do thenables and so forth. But in the asynchronous and multiple, we have observables. And guess what? This code is exactly the same. And that's really the point. Now, let's actually tackle a really hard problem that a lot of people manage to do with their applications, and that's a type ahead, right? Now, how many people have done a type ahead on their own and said, oh, this is a really great idea, I can do it, and I can do it better than anyone else? Okay, I see a few hands. How many people actually got it right, or versus those who gave up? I'm just curious. It sounds like most people gave up. But anyways, it's not exactly easy as you think it is, because you have to debalance the user's inputs. You have to make sure that they're not typing too fast. You have to make sure that the results come in the right order. You have to make sure that you only send over distinct requests, any number of those things. So why don't we try and solve it with this new observables that we've been learning about? Okay? So if I take the key up and now I get the value every time I type, I'm getting this is now an observable of strings, of the input's value. Now what's really interesting is now I can say debounce it by ½ a second, and then distinct until change, because I can continue typing, and I could type, or I could be sitting there hitting the left and right arrow, and that would actually change the key up, but it wouldn't actually change the text. So it would still fire, but I don't want that. I only want distinct values to go through. And then what I can do here, through flat map latest or flat map and switch, what have you, is the idea that we will never, ever get an out-of-order request. And the reason why is it comes in and says, OK, there's a request that's going to go out. And the next time that key up happens, it will cancel the previous request, remove it, and act like it never happened. And the only one that you'll get is the absolute latest. And then you can bind the data directly to the UI, and you're done. So, compare that with what you would have to do normally. There's really not much code that you have to do at all here. In fact, there are a lot of examples of people using React and Angular and so forth with these type aheads, and they realize that the massive amounts of code that they had to write before just doesn't apply. So we can do video polling kind of in the same way. We can think about it in very much the same way, because we're on a hardware-constrained device. We want to make sure that we're keeping only the things on the page in memory, right? So what we can do, just to humor you, is the fact that we can kind of sit here and determine whether the rows are visible or not based upon how we're moving along the screen. And as soon as they're invisible, they disappear. They dispose of themselves. They get rid of all of the the handlers and everything else that they have. And this is actual code that Netflix uses today, which is kind of cool. So if they're solving these really, really hard UI problems, can't you? And the answer is yes, absolutely. So we can take that callback hell that we had before, and then we can do something else, which is really, really nice. So for example, I can retry it 3 times, and I can take until someone hits the cancel button. It's all about composition here. So before, when we had to deal with with callbacks and so forth, we really could burn ourselves easily, as we saw before. But now we can put our hand over that fire, and it's not going to hurt as much. And just as we had these problems with promises of having no finally, I do. You know, we have now we can do any cleanup. We can catch and give you some default data if we want to. That's great. We can do it all. And what's even nicer is the fact that a lot of people are doing a lot of work with React and so forth, as well as Ember. For example, the fine folks at Netflix are using Ember and RX a lot. What's more interesting in this is the fact that Angular has added support for observables as their default for HTTP for moving forward with Angular 2. So as soon as you understand observables, boom, you got it for free. Yay, they've added it. And what's really kind of cool, and I'll talk about that in just a second, is that we're all kind of converging on this idea of observe and reactive. And what was interesting, when they came out and said Angular 2, what do you plan to use for your data access? They said observables, of course. What else would we use? You know, they said Firebase, some said Falcor, some said others, but ultimately, there's a good majority that use some form of observable stuff. And yes, you can use it with React just as well, very, very easily with just some easy stuff. And what's also great in terms of cleaning up after you're done unmounting. Now let's really talk real quickly about the future of JavaScript, because this is important. And that async await is something that we've all been wanting, because like I said, writing standard promise style callback hell is not fun. You know, but the idea of having an async function that you can start to just await each item in a list is really kind of cool. And it's actually accepted into stage 3 going forward for ES 2016. So we've got async awaits and so forth, but you can do the same thing right now with observables, and the fact that we can say results, retry, catch, and finally, and so forth. Dart, of course, is doing something interesting, but nobody cares really, in the fact that they've basically taken streams and observables and combined it into one. But here's the really important part. ECMAScript's observables might actually happen. We might get this directly as part of our runtime. And why that's important is because JavaScript itself does not have any notion of events at all in its system. The DOM does, but not JavaScript. So what if we could actually fix that, where suddenly observables are now your eventing system? So now I can rewrite our mouse moves kind of like this. Not a problem. We can do that, and that would be really, really cool. Now, we're currently working on this here, and it's fairly popular. It gets a couple million downloads a month and stuff like that. But what's more interesting is the fact that we're moving to a new organization and a new code base here for at least our version of observables. And reason why that's interesting is we now have Netflix and Google and Microsoft all working on the same project. We have the Angular team, we have the Netflix team, and we have the Microsoft team all working on a single library. How many people would have thought that a year ago, 2 years ago? I don't know. All right, so if I can tell anyone to remember one last thing about observables, and the fact when you have the iterables, you have pull, we have
Oh my God,
push.
that was rad. I think I can do it too. Push! 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 Dude, let me do one alone! Push! That was good. Wasn't that good?
Thank you.